This is our video on percents, so I will get my picture off the screen and then we'll begin. Here is the outline. We will be talking about calculating with percents, calculating a percent of something, increasing a quantity by a given percent, and then calculating a percent increase. So these are the three kinds of calculations we'll be doing. The shorthand for percent, as you know, is this symbol, little zero slash little zero, and percent means per 100 or over 100. So for example, 15% means 15 over 100, or the decimal form is 0.15. Okay, so changing a percent to a decimal is a fairly easy process. We're changing, so you remove the percent sign and divide by 100. 63% means 63 over 100. And as we know, dividing by 100 means moving the decimal point 2 places to the left. So 63% is 0.63. Going the other direction is simply reversing the process. To change from a decimal to a percent, you multiply by 100 and add a percent sign. And as we know, multiplying by 100 means moving the decimal point 2 places to the right. So 63 in percent form, 0.63, in percent form, is 63%. Changing a fraction to a percent is also an easy process. You do the division to get a decimal, and then you change the decimal to a percent by moving the decimal point 2 places to the right. So 3/4, for example, is 0.75 when you do the division and get a decimal answer, and moving the decimal point 2 places to the right and adding a percent sign gives us 75%. Okay, let's try our first calculation. How do you find 5% of 250? Something I imagine you know how to do. The word of means multiply, so we're going to multiply 5% times 250. To do this, we will have to change 5% to a decimal, at least if you do it on most calculators. Change to a decimal before multiplying. So 5% of 250 is 0.05 times 250. The result is 12.5. And in general, to find our percent of something, you multiply by our percent in decimal form. Okay, here is a slightly different kind of calculation. What percent of 750 is 200? Well, here's one approach to the problem. This is sort of the hard way of doing things. We'll look at the easy way in just a minute. Our percent of 750 is 750 times r, as we know from the previous slide. And we want that, in this problem, we want that to be 200. So we want 750 times r equal to 200. How do you find r? You divide both sides by 750. So r is 200 over 750. 0.2667. On my calculator, I did a little rounding and changing to a percent, 26.67%. 200 is 26.67% of 750. So in general, and this is the easy way to do things, in general, the answer to the question, what percent of A is B, or B is what percent of A, is simply B over A. B is B over A percent of A. And this gives you the decimal form of the percent as in the example. Okay, let's try this problem. Eton Academy is a high school with 151 female students and 125 male students. What percent of the students are female? So the question is asking for the percent of the total student body that are female. So we need to calculate the total number of students. 151 plus 125. That's 276 total students. Of those students, 151 are female. So the percent of female students is 151 divided by 276. Doing this on a calculator gives you the decimal form. We can easily change to a percent. 54.71% of the students are female. Okay, a similar problem, not identical though. 18 is 35% of what number? So we're looking for some number. We will call the number x. So 18, we want 18 to be 35% of x. In other words, 18 should be 0.35 times x. And we're looking for x. To find x, we divide both sides of this equation by 0.35. So x will be 18 over 0.35. And my calculator gave me 51.429. So 18 is 35% of 51.429. Okay, here is another percentage calculation, different from the ones we've done so far. What about increasing 250 by 5%? Well, to increase 250 by 5%, you have to calculate 5% of 250 and then add that to 250. In other words, 250 increased by 5% is 250 plus 0.05 times 250. Okay, I could do the calculations, multiply 0.05 times 250 and add to 250. But instead of doing that, what I'm going to do is just a little bit of algebra. I'm going to factor out the 250. So this is the same as 250 times the quantity, 1 plus 0.05. And the reason I'm doing this is it makes it easier to see what happens in general when you're trying to increase any number by a given percent. So in general, to increase a quantity A by R percent, you multiply by 1 plus R, where R is the decimal form of the percent. In other words, A increased by R percent is A multiplied by the quantity 1 plus R. Decreasing a quantity by R percent is similar. to do a decrease by R%, we multiply by 1 minus R. Okay, let's try applying that that formula. The price of a Snickers bar in Pray Harold vending machines increased from $1.50 to $1.75. What was the percent increase? Well, the increase, forgetting about percentages for a minute, the increase is $1.75 minus $1.50. This is an easy calculation to do. You get 0.25 when you do the subtraction, or 25 cents. But as in the previous slide, I'm not going to do the calculations because we want to get some idea of what happens in a more general setting. Okay, so we need to find what percent of $1.50, the starting price, this referring to the increase. In other words, what percent of $1.50 is $1.75 minus $1.50? We know how to do this. $1.75 minus $1.50. To get the percent of $1.50, that is, you divide by $1.50. So $1.75 minus $1.50 is $1.75 minus $1.50 over $1.50 percent of $1.50. This will give you the decimal form of the percent. Okay, so the percent increase in price, $1.75 minus $1.50 divided by $1.50. I'm simply rewriting that expression. So we're looking at this as being the increase in price, the increase divided by the starting value. And now we will do the calculations. The increase in price was 25 cents. We're dividing that by the starting price, $1.50. I get 1.67, doing a little rounding on my calculator, and changing to a percent gives me 16.7%. So the percent increase was the ending value minus the starting value divided by the starting value. And in general, this is how you calculate a percentage increase or decrease in a quantity. The percent increase or decrease is the ending value minus the starting value divided by the starting value. Sorry about that little glitch. Ending value minus the starting value divided by the starting value. So a positive answer means there was an increase. A negative answer means there was a decrease. And the thing to note here is that percent increases or decreases are always calculated relative to the starting value. Okay, so let's try this problem. The population of a town increased from 3,850 in 2005 to 5,900 in 2012. By what percent did the population increase? To get the percent increase, we take the ending value minus the starting value and divide by the starting value. So the increase, forgetting about percentages, is the starting value minus the ending value. That would be 5,900 minus 3,850. And the percent increase is the ending value minus the starting value divided by the starting value. 5,900 minus 3,850 divided by 3,850. I get 0.532, and changing to a percent gives me an increase in population of 53.2%. Okay, another problem. The value of a stock at the beginning of 2018 was $75. It increased in value by 7% during 2018, and then during 2019 it decreased in value by 7%. So what was the value at the end of 2019? Well, since there was an increase of 7% and then a decrease by 7%, it's tempting to say that the value at the end of 2019 was simply the starting value of the stock. But let's do the calculations. So to get the value at the end of 2018, we take the starting value, which was $75, and we multiply by 1 plus 0.07, because we are increasing by 7%. So $75 times 1 plus 0.07 gives me $80.25. So this is the beginning value for the year 2019. Okay, now to calculate the ending value for the year 2019, since there was a decrease of 7%, we're multiplying the starting value, 80.25, by 1 minus 0.07. So at the end of 2019, the value was 80.25 times 1 minus 0.07, 74.63. So the stock did not return to its original value. And the reason for this is that percentage increases and decreases are always calculated relative to the starting value. So the starting value in 2018 was $75. The starting value for 2019 was $80.25. Okay, sort of similar problem. A town with a population of 20,000 increased in population by 20% 2 years in a row. What was the ending population? And second question, by what percent did the population increase over the 2-year period? Well, the ending population is fairly easy to calculate. For the first year, we multiply the original 20,000 population by 1 plus 0.20 to increase it by 20%. And then for the second year, we multiply that value by 1 plus 0.20 to increase it by 20% again. 20,000 times 1 plus 0.20 squared is the shorthand for this calculation. 28,800 is the final result I got. To calculate the percent increase, now that we have the ending value, is a fairly easy thing to do. It is the ending value minus the starting value divided by the starting value. I get 0.44 when I do that calculation, so 44% was the percent increase over the 2-year period. Another problem, the price of General Motors stock increased by 2% one day and then increased again by 3% the next day. What was the percentage increase for the 2-day period? So, as in the previous problem, the answer is not 2% plus 3%. And the reason is the same as the reason for the previous problem. Percentage increases are always calculated relative to the starting value. So let's do the calculations. Okay, it doesn't matter what the starting price is. This is purely a problem about percents. So I'm just going to choose a starting price and work with that. I should get the same answer no matter what starting price I choose. So I'm going to start with $20. Okay, then at the end of the first day, the $20 was increased by 2%. So that would be $20 times 1 plus 0.02 is $20.40. Okay, for the second day, the beginning value is $20.40. In the second day, the price increase was 3%, so we multiply $20.40 by 1 plus 0.03. The increase, the ending price was $21.01, $21.01. Okay, now we are asked for the percent increase in this problem. The percent increase, as we know, is the ending value minus the starting value divided by the starting value. Okay, so for the two-day period, the ending value was $21.01, and for the two-day period, the starting value was $20. That's in the numerator of the fraction, and then we're dividing that by the starting value. 1.01, after we do the subtraction, divided by 20 is 0.0505, which in percent form is 5.05%. Okay, here is a problem which could be useful later in the course. So we're assuming that in this course your final exam counts for 20% of your grade, and that going into the final exam you have an 82%. In other words, you have 82% of the non-final points going into the final exam. So the question is, what is the highest possible overall percent grade that you could have in the course? So we're assuming that you get 100% of the points on the final. This would give you your highest possible grade. Here again, the total number of points available in the course shouldn't matter for this problem. It's purely about percents. So in this case, I'm simply going to use capital P for the number of points. Okay, and the plan is to find the number of points you will have out of P, possible points, and then divide your points by the total number of points, capital P, to get your percent. Okay, P is the total number of points. That means that 20% of P, or 0.2 times P, is the total number of possible points on the final exam. Right, the final exam counts for 20% of the points. And 80% of P, of the total number of points, which is 0.8 times P, is the total number of non-final points that are available in the course. So we're thinking of the total number of points in the course like this. We're thinking of P being split up between the non-final points, which is 0.8 P, and the points available in the final, which is 0.2 P. So you've got 82% of the first group of points. 82% of 0.8 P, we have to multiply by 0.82. So 82% of 0.8 P is 0.82 times 0.8 P. These are the total number of points you have from the first group of points. And if you get 100% on the final exam, you will have 100% of the second group of points. That's the total number of points available on the final. So that would be 1 times 0.2p, or 0.2p points on the final. So your total number of points will be what we figured to be your total number of non-final points, 0.82 times 0.8 times p, plus the number of points you get on the final. So adding multiplying 0.82 times 0.8 and adding to 0.2 gave me 0.656. Oops, sorry, that's just multiplying 0.82 by 0.8, gave me 0.656. Times p, we're adding that to 0.2p, so 0.856p is your total number of points in the course, assuming that you get 100% on the final. Okay, our plan was to take your total number of points and divide by the total number of points available to get your percent score. So 0.856p divided by p. The p's cancel, so as we suspected at the beginning, the value of p doesn't matter. We get 0.856, and in terms of percents, 85.6% is the best you can do overall in the course. Yeah, well, it might be easier, instead of using capital P for the total number of points in that last example, it might be easier to pick a specific number, and choosing p equals 500 works out pretty well. So I'm going to try redoing the problem, assuming that there are 500 points available in the course. Okay, with this choice of p, the number of non-final points would be 80% of 500. That's 0.8 times 500. So there are 400 non-final points available. And the number of points on the final is 20% of 500, or 0.2 times 500. That means 100 points available on the final. Okay, we're assuming that you have 82% of the 400 non-final points and 100% of the 100 points on the final. So your point total is 0.82 times 400 plus 100 is a total of 428 points. What is the percent? What percent is this of the total number of points, of the total 500 points? Your overall percentage is 428 divided by 500, 0.856, or 85.6%. All right, we're going to finish up with a quick summary of calculating with percents. So, number one, are you dealing with a percent of some quantity? The formula is that R percent of a quantity Q is R times Q, where R is in decimal form. If you are increasing or decreasing a quantity by R percent, we've seen that the formula or formulas are, you get the ending value by taking the starting value and multiplying by 1 plus R for an increase, or multiplying the starting value by 1 minus R for a decrease. So, final formula, are you dealing with a percent change? The formula is that the percent change in a quantity is the ending value minus the starting value divided by the starting value.